We start now the presentation for the final part of chapter 10, which we have named as module 2. Recall that in the first module we have introduced the formal definition of Riemann-Stieltjes integral by using the notion of Riemann-Stieltjes sum. Now, when you have studied the theory of Riemann integration in undergraduate level, you know that there are two approaches to define Riemann integral. One is through consideration of Riemann sum and the other is through consideration of upper and lower sums, and that particular approach gives us the definition of Darbaux integral. And we know that a function is Riemann integrable if and only if it is Darbaux integrable. In this case also, we will now consider another approach in the line of Darbaux integrals and will finally show that both the approaches are equivalent. So, we now give the formal definition of Darbaux Stieltjes integral. Let f be a bounded function defined on closed interval a b, and let p a equal to x 0 less than x 1 less than x n equal to b be a partition of closed interval a b. As always, let us denote by capital M K f as supremum x belonging to closed interval x k minus 1 x k f x and small m k f as infimum x belonging to closed interval x k minus 1 x k f x. We define the upper and lower Darbaux Stieltjes sums as u p f alpha equal to sigma k equal to 1 to n capital M k f delta alpha k and L p f alpha as sigma k equal to 1 to n small m k f delta alpha k. Suppose that alpha is an increasing integrator on closed interval a b. Then see that it is an easy observation that the three sums are related by this relation, that L p f alpha less or equal to S p f alpha less or equal to u p f alpha. For two partitions p and p dash of closed interval a b, if p is contained in p dash, that is p dash is a refinement of p, then we have L p dash f alpha greater or equal to L p f alpha and u p dash f alpha less or equal to u p f alpha. That is, when we take refinements, the lower sums increase and the upper sums decrease. For any two partitions p 1 and p 2 of closed interval a b, just as in the case of Riemann integral or more precisely Darbaux integral, we can show that L p 1 f alpha is less or equal to u P2 F alpha, that is the upper sum for any partition is greater or equal to the lower sums of all the partitions. So, if f is a bounded function defined on closed interval a b, and if alpha is an increasing integrator on closed interval a b, the upper Darbaux Stieltjes integral of f with respect to alpha is defined as upper integral a to b f d alpha is equal to infimum of all these sums u p f alpha, where the partition P runs over pi a b, and the lower Darbaux Stieltjes integral of f with respect to alpha is defined as lower integral a to b f d alpha equal to supremum over L p f alpha, where P runs over all partitions of closed interval a b. And it is an easy observation from the fact that every lower sum is always less or equal to every upper sum, that the lower integral is always less or equal to the upper integral. So, finally, a bounded function f defined on closed interval a b is said to be Darbaux Stieltjes integrable with respect to the integrator alpha on closed interval a b if the lower and upper Darbaux Stieltjes integrals are equal. Now, we consider a condition which is known as Riemann condition. A function f closed interval a b to r is said to satisfy Riemann condition with respect to the integrator alpha on closed interval a b if for every epsilon greater than 0 we can find a partition p epsilon with the property that for any partition p which is finer than p epsilon, we have 0 less or equal to u p f alpha minus L p f alpha less than epsilon. Now, from the definition of Riemann condition, it is an easy consequence to see that a function f is Darbaux Stieltjes integrable if and only if it satisfies the Riemann condition. The proof is exactly similar to the Darbaux theorem for Riemann integration. Now, we are going to show that if f is a bounded function defined on closed interval a b and alpha is an increasing integrator on closed interval a b, then f is Riemann Stieltjes integrable on closed interval a b if and only if f satisfies the Riemann condition with respect to alpha on closed interval a b. So, if we can prove this result, we already know that f is Darbaux Stieltjes integrable if and only if it satisfies the Riemann condition. So, combining the two results we get our desired equivalence, that the Riemann Stieltjes integrability of f is equivalent to Darbaux Stieltjes integrability of f for a bounded function f and when the integrator alpha is an increasing integrator. So, formally let us just state the theorem that if alpha is an increasing integrator on closed interval a b, then a bounded function f is Riemann Stieltjes integrable on closed interval a b, if and only if upper integral is equal to lower integral, that is it is Darbaux Stieltjes integrable on closed interval a b. Let us start the proof. Suppose that f is Riemann Stieltjes integrable with respect to the increasing integrator alpha and the value of the Riemann Stieltjes integral is equal to capital A. Now, first observe that if alpha A is equal to alpha B, then as alpha is increasing, so alpha must be a constant function on closed interval a b, and in that case the Riemann condition holds unconditionally. পরের স্লাইডটাতে একটু যাও, দেখি কতটা লেখা আছে, পুরোটাতে চলে যাও, না 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 পরে. So, let us now assume alpha A is less than alpha B. Let epsilon greater than 0 be given. Then, from the definition of Riemann Stieltjes integrability of f, we can find a partition P epsilon of closed interval a b such that for any partition P of closed interval a b which is finer than P epsilon, the difference between the value of the integral and the corresponding Riemann Stieltjes sum is less than epsilon by 3 for any choice of intermediate points. So, if we choose any two points tk and tk dash from closed interval xk minus 1 xk for k equal to 1 to n, we have mod sigma k equal to 1 to n f t k delta alpha k minus capital A less than epsilon by 3, and this is also true when we replace t k by t k dash. Consequently, observe that mod sigma k equal to 1 to n f t k minus f t k dash into delta alpha k, this is less than 2 epsilon by 3. Hence, if we consider the difference between the upper Darbaux Stieltjes sum and the lower Darbaux Stieltjes sum, u p f alpha minus L p f alpha, this is equal to sigma k equal to 1 to n capital M k f delta alpha k minus sigma k equal to 1 to n small m k f into delta alpha k, and this is equal to sigma k equal to 1 to n bracket capital M k f minus small m k f into delta alpha k, and this is less than sigma k equal to 1 to n f t k minus f t k dash plus delta into delta alpha k, where we choose delta as epsilon by 3 into alpha b minus alpha a. and this is equal to sigma k equal to 1 to n f t k minus f t k dash delta alpha k plus delta into sigma k equal to 1 to n delta alpha k. This is again less than 2 epsilon by 3 plus epsilon by 3 into alpha b minus alpha a into alpha b minus alpha a, and this sum is equal to epsilon, and this shows that f satisfies the Riemann condition with respect to the integrator alpha. For the converse, we now assume that f satisfies Riemann condition with respect to the increasing integrator alpha on closed interval a b. Let epsilon greater than 0 be given. Then from the definition of Riemann condition, there exists a partition P epsilon such that for any partition P which is finer than P epsilon, we have 0 less or equal to u p f alpha minus L p f alpha, this is less than epsilon. Then it follows that the upper Darbaux Stieltjes integral a to b f d alpha, this is less or equal to u p f alpha, but this is less than L p f alpha plus epsilon, and this is again less or equal to the lower Darbaux Stieltjes integral plus epsilon. Since this relation is true for any epsilon greater than 0, so we get the upper integral is less or equal to the lower integral. But we already know that the lower integral is always less or equal to the upper integral. So, combining we have hence lower integral a to b f d alpha equal to upper integral a to b f d alpha equal to capital A say. Now, choose an eta greater than 0. Then there exists a partition P dash eta such that for any finer partition P of P dash eta, we have u p f alpha less than upper integral a to b f d alpha plus eta. Also, we can find a partition P double dash eta such that for any finer partition P of P double dash eta, we get L p f alpha greater than lower a to b f d alpha minus eta. So, again choose P eta as P eta dash union P eta double dash. Then for any partition P finer than P eta, we have lower integral a to b f d alpha minus eta, this is less than L p f alpha, this is less or equal to S p f alpha, and this is less or equal to u p f alpha, and this is again less than upper integral a to b f d alpha plus eta. and this shows that capital A minus eta is less than SPF alpha less than capital A plus eta, and consequently we have the observation that f is Riemann-Stieltjes integrable on closed interval a b with respect to the integrator alpha with the value capital A. We now just state this theorem without going into the proof. If f and alpha are increasing functions on closed interval a b and f is Riemann-Stieltjes integrable with respect to the integrator alpha on closed interval a b, then alpha is also Riemann-Stieltjes integrable with respect to integrator f on closed interval a b, and we have integral a to b f d alpha plus integral a to b alpha d f is equal to f b alpha b minus f a alpha a. The proof is given in details in the course content. We will not go into the details of the proof in this presentation. We can also prove the existence of antiderivative here. Let alpha be a function of bounded variation on closed interval a b and assume that f is Riemann-Stieltjes integrable with respect to the integrator alpha. Define the function capital F on closed interval a b by capital F x equal to a to x f t d alpha t. Then the function capital F has these properties that capital F is a function of bounded variation on closed interval a b. Every point of continuity of the integrator alpha is also a point of continuity of capital F. If alpha is increasing on closed interval a b, then the derivative capital F dash c exists at each intermediate point c belonging to open interval a b, where alpha dash c exists and the function f is continuous, and capital F dash c is actually equal to f c into alpha dash c. Finally, we just give some examples how to calculate the values of Riemann-Stieltjes integral. We will consider these three Riemann-Stieltjes integrals 0 to 2 x square dx square, 0 to 2 box x dx square and 0 to 3 box x d e to the power x. Consider the first Riemann-Stieltjes integral 0 to 2 x square dx square. This is equal to 0 to 2 x square into 2x dx by a known formula. So, this is equal to 0 to 2 2x cube dx. So, this is equal to 2 cube and the value is equal to 8. If we consider the second integral 0 to 2 box x dx square, this is equal to 0 to 1 box x into 2x dx plus integral over 1 to 2 box x into 2x dx. We just divide the interval into two parts, and the value of the first integral is 0 and the value of the second integral is 3, and so the value of the required integral is 3. Finally, if we consider this Riemann-Stieltjes integral, integral 0 to 3 box x d e to the power x, this is equal to 0 to 1 box x e to the power x dx plus integral 1 to 2 box x e to the power x dx plus integral 2 to 3 box x e to the power x dx, and the value becomes e square minus e plus 2 into e cube minus e square. So, in all these results we have actually used that particular result, that when the integrator has continuous derivative in closed interval a b, the Riemann-Stieltjes integral of f with respect to the integrator alpha is given by the Riemann integral of f alpha dash. So, to summarize, what we have done in the last module, module 2 of chapter 10, is that we have found an equivalent criteria for Riemann-Stieltjes integrability, and we have shown that we can define Darbaux Stieltjes integrability of a bounded function f by using the upper and lower Darbaux Stieltjes sums, and finally we have observed that for a bounded function f defined on closed interval a b, with respect to an increasing integrator alpha, f is Riemann-Stieltjes integrable if and only if it is Darbaux Stieltjes integrable. And with this comment we finish this module.